So good morning. Am I audible?
Yes, sir.
So last class we have discussed this problem. Let us complete this problem. So which completes the resultant of non-coplanar, non-concurrent force system. Now, this is a dam structure. It is subjected to the forces as shown in figure. So these are the forces acting on the dam. So I think this we have already done. So this problem, last class we were discussing about this problem. And here, so this angle is 60. Obviously, this angle is also 60. And if you draw a horizontal line over here, so this angle will be 60, this angle. So obviously, the remaining angle will be 30. So this force makes an angle 30 degree with respect to the x-axis, correct? Now, so we need to find the magnitude, direction, and the position of the resultant. And also we should find the point of intersection of the resultant with the base of the dam, whether it is within 1/3 base or 2/3 base. So for the stability analysis. Now first let us consider the reference axis x and y. Then we shall try to find the sum of horizontal components, sigma f of x. So in this case, sigma f of x is 50 minus 30 cos 30. 50 minus 30 cos 30. So whatever the value of sigma f of x you get, 50 minus 30 cos 30. So next is sigma f of y. So sigma f of y, you have 120 Newton force acting in the downward direction. And also if you resolve this for its vertical component is 30 sine 30, 30 sine 30. So hence sigma f of y is minus 120 minus 30 sine 30, 30 sine 30. So here sigma f of x will be obviously, I think it is positive, and sigma f of y is negative, hence the resultant lies in the fourth quadrant. So first you find sigma f of x, so 50 minus 30 cos 30, and sigma f of y is minus 120 minus 30 sine 30. So whatever the value you get, so then find the magnitude of the resultant, r is equal to square root of sigma f of x square plus f of y square. Then you find the angle of the resultant, that is tan alpha or tan theta. Theta is tan inverse sigma f of y by sigma f of x. You will get the direction of the resultant. Next, you need to find the position of the resultant. So now let us consider this point as the origin of the coordinate axis. So let us call this point as say A. So let us take moment of all the forces with respect to point A. So sigma MA. So 50 into 2. So it creates a clockwise movement about this point. Now you have a 120 kilonewton force acting in the downward direction. So 120 into, so this distance being 2 meters. So it also creates a clockwise movement about this point. Now we have to resolve this force. So this is 30 cos 30 acting in this direction. And this is 30 sine 30 acting in the downward direction. Now, so let us consider this as a triangle. This is so drop a dotted line over here. So now we have to find, so you call this point as something, let us call this point as small a, b, c. So this is the triangle. So in order to calculate the moment, we need the perpendicular distance for these individual components about O, correct? Now here, so this 30 kilonewton force, its horizontal component is acting like this, 30 cos 30, and the perpendicular distance with respect to this point is this height you have to calculate. This height, that is the opposite side of this triangle. Now, we know the hypotenuse, correct? It is 1.25, and we know this angle, theta is, or whatever the angle, this angle is same, correct? 60 degree. So here, sine theta is opposite side by the hypotenuse. So thereby you will get this distance, correct? So while taking the moment 50 into 2, 120 into 2, so this horizontal component of this 30 kilonewton causes an anti-clockwise movement because it is acting in this direction, and the perpendicular height is this one, that is this height. So that is given by sine 60. Sine theta is nothing but sine 60. That is, you can call this side as say AB. So that is nothing but AB divided by 1.25. So thereby you will get this value AB. Next, And for the vertical component of this 30 kilonewton force, it is acting like this in the downward direction. And the perpendicular distance is this one. From this point, whatever the line that you draw here, it will be intersected at this point. And this distance you want, because force into perpendicular distance. So this also creates a clockwise movement. Now you have to calculate this side, correct? So cos theta means, say if you consider this as a triangle ABC, so ABC, so you want this AC, correct? AC, this distance. So if you deduct this one from the total distance, you will get the perpendicular distance for the vertical component of this force from this point to this point. So now this side, that is AC, is nothing but cos theta. Cos 60 is equal to AC divided by 1.25. You will get this distance. So you deduct from this point to this point, you require distance. So this total is 6. So you deduct this AC length, then you will get the remaining distance. So hence the perpendicular distances for this component forces are the opposite side and the adjacent sides of this small triangle. So finally find sigma MA at this point, considering all the forces. Whatever the value of sigma MA you get, so it will be Newton meter, whether it may be a clockwise or anti-clockwise movement. So once you find sigma MA, then next is R into D. R into D is equal to sigma MA, where you will get the position of the resultant. That is D in meters or centimeters, whatever dimensions may be. Then once you find the position of the resultant, then comfortably you can find the X and Y intercept of the resultant, where exactly the resultant cuts the horizontal and vertical axis. That is the vertical height and the horizontal distance from the axis of reference. That is the point of reference, the origin of the coordinate axis. So these types of problems, only thing is you have to follow the steps. First, always select the reference axis whenever you start with a problem of whether it may be a concurrent force system or a non-concurrent force system. Then find the sum of horizontal components. Then find the sum of vertical components. Then compute the magnitude of the resultant. Next, compute the direction of the resultant. Then you find the sum of moments of all the forces with respect to any given point. Then equate it to the moment of the resultant. Thereby you will get the position of the resultant. Once you get the position of the resultant, then next you need to calculate the X and Y intercept values. So this completes the resultant of coplanar non-concurrent force system. So next, so have you understood this problem? Is anyone having any doubts? Have you understood this problem? May anyone can ask whether you say yes or no, so that I can continue with the next.
Explain on, sir.
The concept is clear. Hello.
Explain on second, sir.
ಇನ್ನೊಂದ್ಸತಿ ಹೇಳ್ಬೇಕಾ?
Yes, sir.
Okay, fine. Now, so which one? Whether sigma f of x or sigma f of y are regarding the moments? Where you have the doubt? So from the beginning,
Yes, sir.
From the beginning, I have to tell this. Okay. Okay, let it. So first you select the reference x. Now you can call this point as say A, B, C, D, E, correct? So call these points as A, B, C, D. Next, take the reference axis right over here, a y axis, and this is x axis. Next, find the sum of horizontal component. So you take a piece of paper and pen, sigma f of x, that is 50, because this force is acting parallel to x-axis. So it is 50 kilonewton acting towards positive direction. Now you have this force, which is at a distance, say 1.25 from point F. So you can call this point as G, okay? So this distance you know. Now here this angle is given. The slope line makes an angle 60 degree with respect to the horizontal axis. Similarly, if this angle is 60, obviously this angle is also 60 degree, correct? This angle is also 60 degree. Now, if I draw a horizontal line here, correct? Here again, this angle, this angle with respect to horizontal, and this is the slope of the structure. So if I draw a horizontal line parallel to this, obviously this angle is 60. The remaining angle is how much? 30 degree, because this whole angle is 90. So if you take, so this is 60, and if you draw a horizontal line, this is also 60. The remaining is 30. So sigma f of x is 50 minus, so if you resolve this force, its x component is minus 30 cos 30. So what is the value of sigma f of x? 50 minus 30 cos 30. So tell me the value, anyone?
24.0.
20? How much it is? 50 minus 30 cos 30.
24.01.
24.01. Is it positive? Yes, 24.01 kilonewton. So it is positive. So next, sigma f of y. Sigma f of y. So you can see here, this is minus 120 acting in the downward direction. And if you resolve this force, its y component is acting in the downward direction, because this force is directed to the third quadrant. In third quadrant, f of x is negative and f of y is also negative. So f of y is nothing but 30 sine 30 acting in the downward direction. So sigma f of y minus 120 minus 30 sine 30. So how much it is?
Minus 135 kilonewton.
So minus 135 kilonewton. So sigma f of x is 24 point something positive, and sigma f of y is, and that is minus 134 something. So resultant lies in the like this. It will act like this. It will pass through y-axis, and it will also intersect x-axis, and it will be in the fourth quadrant. Now sigma f of x is 24 point something, and sigma f of y is minus 134. So find the magnitude of the resultant. R is equal to square root of sigma f of x square plus sigma f of y square. What is the answer?
137.12 kilonewton.
Newton meter. That is moment. Okay, be careful. Sorry, resultant. R is equal to square root of sigma f of x square plus f of y square. How much it is?
137.12 kilonewton.
137.12 kilonewton. So next, find the direction of the resultant. Theta is equal to tan inverse sigma f of y divided by sigma f of x. That is, sigma f of y is 134 point something, and sigma f of x is 24 point something. So tan inverse of that, you will get the direction of the result. That is alpha or theta. How much it is?
79.91.
79 point something. Okay. Hello.
Yes, sir.
My voice is clear, or it's breaking up?
Clear, sir.
So what is the angle? Alpha or theta?
79.91.
79.91. So roughly equal to 80 degrees. Okay. Now we have calculated the magnitude of the resultant direction. Next, we need to calculate the position of the resultant. So position of the resultant, we have the basic equation. R into D is equal to sigma m. Sigma m is the sum of the moments taken at any point. So here let us consider the moment about point A. So now this is the origin of the coordinate axis through which the x and y axis passes. Now basically moment means is a product of force into the perpendicular distance about which you consider the moment. So the moment may be either clockwise or it may be anti-clockwise. So we shall consider all clockwise movements as positive and all anti-clockwise movements as negative. Now before we start with this, because here we have a force and the horizontal component is 30 cos 30 and its vertical component is 30 sin 30. So now for this horizontal component, if you project this, this becomes the perpendicular height. Correct? Now you construct a small triangle over here. Correct? So let us call this triangle as small A, B, and this is point F, and this is point G, and let us call this point as H. Now, HFG, you consider this triangle, HFG. Now, we want HG, this distance, because for the horizontal component, the perpendicular height becomes this one. Now, find this height HG. So that is sine 60. So this angle is sine 60. Sine 60 is equal to Hg divided by 125. How much it is? So Hg is nothing but sine 60 is equal to Hg divided by 125. So Hg is nothing but 125 sine 60. How much it is? Hg, value of this Hg? It is 125 sine 60, 1.25 sine 60. How much it is?
108.25.
No. 1.25 divided by sine 60.
1.08.
1.08. So this Hg height is 1.08. Now you find HF from this point to this point. HF. So this HF will be nothing but cos 60. Cos 60 is equal to HF divided by 1.25. HF is equal to 1.25 divided by cos 60. How much it is? HF is equal to 1.25 cos 60. How much?
0.625.
0.625. 0.625. Now we shall take the moment of all the forces with respect to this point. You write sigma MA. Sigma MA is equal to 50 into 2. So this is the perpendicular distance. 50 into, this is the line of action, and this height is the perpendicular distance. It creates a clockwise movement. So 50 into 2 plus, if you project this one, see it is acting like this. And if you consider the moment, so this force into perpendicular distance, the perpendicular distance is 2 meters. So 50 into 2 plus 120 into 2, 120 into 2. And this horizontal component of this force is 30 kilonewton, 30 cos 30. And the height with respect to point A is this height we have calculated, that is Hg. So minus 30 cos 30 into 1.08, this height, 1.08. So sigma MA is 50 into 2 plus 120 into 2 minus 30 cos 30 into 1.08. Next, the vertical component of this force is acting like this, and this distance you have calculated as 0.625. So the remaining distance from this point, that is HA. So plus 30 sine 30 into 6 minus 0.625. So this total distance is 6. So if you take out this, the remaining distance, that is 30 sine 30 into 6 minus 0.625. So you get the sum of moments, sigma MA. How much it is? Anyone? 50 into 2 is 100. 120 into 2 is 240. So 340. 340 minus 30 cos 30 into 1.08 plus 30 sine 30 into 6 minus 0.625. What is the sum? Sigma MA? Anyone? Anyone has done it?
392.56.
392.56 Newton meter. It is positive, no? Positive value.
Yes, sir.
Okay, you find the sum of moments as 392,
92.56.
92.56 Newton meter. Now, you know the magnitude of the resultant. R into D is equal to sigma MA. R D is equal to sigma MA. That is whatever the value you got, 592 something, that divided by the resultant value you got. How much it is? R. So you'll get the position of the resultant D.
2.86.
2.86. Okay. The resultant is somewhere here. It is acting like this. That is within the one-third base. Now the resultant is acting like this, and this is the perpendicular distance, position of the resultant. That is, you calculated as how much it is? 2.4 something. D, value of D.
2.86.
2.86. Okay,
Yes,
whatever.
sir.
Okay, whatever the value you get, you right. Now you can find x-intercept. So x-intercept is nothing but sigma MA divided by sigma f of y. So you will get this distance where the resultant cuts. This is x-intercept. Suppose if I draw a line like this, it may cut here. So I want this distance. X-intercept
2.990.
Okay, x is 2.90 and y-intercept sigma MA divided by sigma f of x. How much? What is the answer? Sigma MA divided by sigma f of x.
16.34.
So here somewhere the height is somewhere here. So y, that is y-intercept, whatever it may be. The formula remains same. Either it is x-intercept or y-intercept. So the resultant is cutting like this. And it is making an angle somewhere around 79.9 something. And the x-intercept value is about 2.9 something. So now you have understood how to solve the problems under coplanar non-concurrent force system. I think the concept is clear with this problem. Okay, fine. Now, next chapter is under the force system, equilibrium of coplanar concurrent force system. So now let us first understand what we mean by the word equilibrium. So equilibrium is nothing but the body is under, when the body is under equilibrium condition, it is said that, and the resultant of all the forces, whether the system of forces may be concurrent force system, parallel force system, or non-concurrent force system, the body is subjected to any kind of force system, any system of forces, but it is under equilibrium condition. So this condition is satisfied only when the resultant of all the forces, acting on the body must be equal to 0. So when the resultant of all the forces acting on the body is 0, then the body is said to be under equilibrium condition. And the body may be subjected to a coplanar force system, coplanar concurrent force system, where you need to calculate the sum of horizontal components, sum of vertical components, and thereby you have to calculate the magnitude of the resultant and also the direction of the resultant. Where when you deal with the equilibrium condition for a concurrent force system, the necessary and sufficient conditions for equilibriums are the sigma f of x should be 0 and sigma f of y should be 0. So if sigma f of x is 0 and sigma f of y is 0, hence the resultant will also be 0. So that is the necessary and sufficient conditions for equilibrium of a coplanar concurrent force system. That means sigma f of x is 0. That means the sum of horizontal components must be equal to 0 and the sum of vertical components must be equal to 0. Hence, the resultant will have a zero value. That means the body is under equilibrium condition. So similarly, for equilibrium of coplanar non-concurrent force system. So there are two types of force system acting on a body which is under equilibrium condition. One is the coplanar concurrent force system. The other one is the coplanar non-concurrent force system. So in case of coplanar concurrent force system, the necessary and sufficient conditions for equilibrium are sigma f of x, that is sum of horizontal forces must be zero and the sum of vertical forces must be zero, and also the resultant will be zero. Whereas in case of equilibrium of coplanar non-concurrent force system, so the necessary and sufficient conditions for equilibrium are the sum of horizontal components must be zero, the sum of vertical components must be zero, and also the sum of moments of all the forces about any required point should be equal to zero. So a body is said to be under equilibrium condition when the resultant of forces acting on the body is zero. Now let us go through the theory of equilibrium. Now equilibrium. So when a stationary body, that is a body which is at rest, is subjected to external forces, and if the body remains in the state of rest under the action of forces, it is said to be equilibrium. So this action of forces may be either external action or it may be an internal action. So the external action leads to cause the motion of a body, whereas the internal action leads to the deformation like stresses and strain. So a body is said to be under equilibrium forces under the influence of an external force system. That means the body remains at its state of rest. It's called as the equilibrium. Now, the principle of equilibrium. According to this principle, a body is said to be in equilibrium if algebraic sum of all the forces acting on the body is zero, and also the algebraic sum of moment of the forces about any fixed point is zero. That means if you have a concurrent force system, acting on a body, the necessary and sufficient conditions for equilibriums are sigma f of x is zero. You can see here sigma f of x is zero and sigma f of y is zero, and hence the sum of this sigma f of x and sigma f of y is nothing but sigma f is also zero. That is, the resultant value is also zero. And in case of non-concurrent force system, so the necessary and sufficient conditions for equilibrium are sigma f of x is zero, sigma f of y is zero, and the sum of moments of all the forces acting on the body should be equal to zero. Now, a body is said to be in equilibrium if there is no translation and no rotation of the body under the application of external forces. If the body is not moving in either translation motion or in rotation motion, so then the body is said to be under equilibrium condition. So in all our civil engineering applications, we always deal with the equilibrium. That is, we always speak with the static equilibrium condition of a body. So whenever we want to design any structure, we consider the equilibrium condition of the structure, because the structure may be subjected to a concurrent force system or a parallel force system or a non-concurrent force system. In such a case, we need to find the sum of the resultant of all the forces must be equal to zero. So that is the main concept that we use in the design of structures, where we consider the structure to be under the static equilibrium condition, correct? So anyway, I request all of you to mark your attendance in the chat box. The time is running out. So we shall meet on Tuesday morning. You have my class. We'll continue the class. And I think your first test starts from 2nd of July, I think, correct? Hello? Your first online internal starts from 2nd of July. Hello, can you hear me?
Third, sir.
Okay, so the portions for this subject for first online internal or it may be offline interval. So the starting, whatever the starting first chapter we have discussed, that is the classifications of force system, the law of parallelogram of forces, Verigno's theorem, the concept of moment and couple, and also the resultant of concurrent force system, the resultant of coplanar concurrent force system, whereas the resultant of non-coplanar concurrent system will not be included in the first internal. So the portions for the first internal is the first chapter, whatever the first chapter, and also the resultant of coplanar concurrent force system. Part B will have the derivations on centroid and also the numerical problems on centroid. So that is the portion for your first session. So anyway, I have completed all those things and also shared the notes to you. So any more questions you have? So I'm ending the class. If you don't have any questions, I will be ending the class. Hello, anyone? Jeevan Kya? Mr. Jeevan Kya? Are you there? Mr. Jeevan K. Amit? K. Amit? Likit Kumar?
Yes, sir.
Nitin, yes?
Yes, sir.
Okay. Anyway, so thank you so much for attending the class. So we'll continue the class next on Tuesday. Till then, have a nice day. Stay safe. Goodbye.